In section 6.4, we explore a really useful theorem called the central limit theorem. And this tells us something pretty remarkable about samples. In particular, the random variable x is assumed to be any distribution. It could be a normal distribution or not normal, as long as the sample size is large enough. When we take samples of this population, it'll tend to be a normal distribution. So regardless of the distribution of our parent population, the samples that we take will have a sampling distribution that approaches a normal distribution. And so the remarkable thing is that regardless of what the distribution that we're starting with in the population, the samples will always tend to be normally distributed. And then the mean of all the samples is equal to the population mean. So here the mean of our sample means is going to be equal to the population mean. And then the standard deviation of the sample means will be smaller than the population depending on the sample size. So, for instance, if I take a very large sample, then the variance of the means, in other words, the variation between the different means that I get, is going to be much smaller. In other words, the larger the sample size, we can expect the means that we get in each of the samples to be much closer to each other. In other words, they should tend to be really close to the population mean whenever I take a sample mean. And so the bigger the sample size, the bigger n is, the smaller the standard deviation is. Now, a great way to visualize this is to look at the animation that's available here at this link. And we'll explore this this simulation in the lectures in class. So so we can revisit this in another video. So some other things to consider about the distributions. If the original distribution is normally distributed, then for any sample size n, the sample means will be normally distributed. So in this case, you can take very small samples, right? Any sample size. So you could take very small samples, and the means will tend to be normally distributed. On the other hand, if the parent population, if the original population is not normally distributed, then we need a relatively large sample size. In this case, it needs to be 30 or bigger than 30 in order for the sample means to be approximated by normal distribution. So really, in this case, having a larger sample size will guarantee that regardless of the distribution, the sample means will be normally distributed when we look at the sampling distribution. And so here we can imagine, given a normal distribution where the mean is 10 and the standard deviation is 3, and we're taking samples of n, size n equals 9. Right, so we can imagine here our original population has a mean of 10 with a standard deviation of 3, and our standard deviation of this has a standard deviation of 3. Well, we know that because our original population has this normal distribution, right? This is a normal looking distribution here. We know that the sampling distribution will also be normally distributed, although I can imagine it will be have a smaller standard deviation. We know that the mean of our sampling distribution will also be 10. It'll be the same as our simply as our original population, but the standard deviation here will be smaller, so it's going to be a narrower bell curve there. So it'll be a skinnier curve. And in fact, here we can compute the standard deviation of our sampling distribution by taking the original standard deviation and divide it by the square root of n. So we'll have 3 over the square root of 9. So that's 3 over 3, which is 1. So here our standard deviation for the sampling mean, or for the sample means, is 1. So we know this has to be a smaller standard deviation than the original population, but they have the same mean. And say we're given a distribution where the original population has a mean of 77 and a standard deviation of 14, and suppose we're taking samples of size n equals 49. Notice in this case it's not a normally distributed graph, but because here the sample size is bigger than 30, we can assume that the sampling distribution will also be normally distributed with the same mean as the population, which is 77. But notice that, yeah, here, because of the way this original population is, right, the mean of our original population is also 77, it's not normally distributed, but because we're taking large samples, our sample means are going to be normally distributed. So here the mean of our sample means is the same as our population mean, although here the standard deviation would be smaller, right? So the standard deviation of our sampling distribution would be equal to the standard deviation of the population divided by the square root of n. So we'll have 14 divided by the square root of 49, which is 7. So 14 divided by 7 is 2. So we see this has a smaller standard deviation than our population. And the graph of the sampling distribution has to be normal.